fellas? Okay, addition of fractions, done. Subtraction of fractions, done. We are now moving on to multiplying fractions. Honestly, I feel like multiplying fractions is going to be the easiest of all four operations. Multiplication seems like that would be harder, right, than addition or subtraction, but it's really not. Why? Because there is a key thing that you do not have to do when multiplying fractions. You no longer, for multiplying fractions, need to find a... No, you don't even need to do that anymore. That's one huge big step. No finding a common denominator, no writing equivalent fractions. You're going to go right to multiplying them. Easy peasy. So, what I want to do right now is we're going to we're going to begin just the intro part of lesson 8-4. Don't turn to it in your books right now. Just I want you to listen. I want you to pay attention to what we're going to do. This is like some foundational work for something called scaling fractions. Sounds scary, but it's not. So, keep your hands down until we're done with this little chunk, and then you can ask your questions all at the end. So, scaling fractions, that's just a term. Put that aside and just think about what I've got on the board here. Multiplying. Okay, there is something, if you remember back to when we did our unit on multiplication, called the identity principle. Anybody remember what it is? The identity principle. Remember principles of multiplication. One of them was the identity principle. It said, Mia?
That anything times itself. So anything times 1 in multiplication will be itself.
Anything times 1 equals itself. We're going to take that and we're going to apply it first as the first thing we learn about multiplying fractions. So any fraction or mixed number that you put here, any one of them, times 1 is going to equal itself. So we could put 2 3/5 here. Times 1 equals 2 3/5, right? We could put something like an improper fraction like 32/6. 32/6 times 1 equals?
36.
Easy peasy. Anything times 1 equals itself. Okay, we're going to use that principle with something called scaling fractions. So let's just say we are going to put in here 2 2/3. That's just what we're going to use. But this could be any mixed number, fraction, improper fraction, anything you want to put here. Okay? Anything. We're really concerned with this factor, not this one. You can put anything in here. We're concerned about this one and seeing what you get for an answer. Any mixed number times 1 is going to equal the same number. Now, all we're doing with fractions is we're saying we're going to replace this 1. We're going to replace this with a fraction. What fraction could we put in the place of 1 that's equal to 1? Give me an example of a fraction that is a whole fraction, meaning it equals a whole. Charlotte? Say it again. 3/3. So if we said 2 2/3 times 3/3, would it equal 2 2/3?
Yeah.
Yes, because this is the same as saying 1. And any number times 1 equals itself. So any number times 3/3 would also equal itself. Does that make sense? It looks really complicated, like if you were doing your Iowa testing and you said 2 2/3 minus 3/3, oh my goodness, I don't know how to multiply fractions. But you do, because this really isn't a fraction. It could also be a whole. Any number times 1 equals itself. Give me another example of what you could use here that is going to equal itself. Mia?
4 4.
Well, no, because that has a whole number. So that would actually, 4 4, 4, so that should be 5. So if you take this times 5, it's going to be bigger. We need a fraction that just equals 1 whole. Bodie?
8/8.
8/8 would work, for sure. 8/8 equals 1. So anything times 8/8 is going to equal itself. It's going to be equal to. Does that make sense? What's another fraction that if I multiply anything by this whole fraction, it's going to equal itself? Michaela?
100 over 100.
Yes. Anything, any number, times the fraction 100 over 100 is going to equal itself. 2 2/3 times 100 hundredths equals 2 2/3 because this really is one whole. Mia?
Are you still doing that?
You bet. Give me another one.
A million times million?
1 million over 1 million. So 1 million, 1 millionth. This number times 1 million, 1 millionth equals itself because 1 million, 1 millionth is really one whole. So the idea is anytime you take a fraction times a whole fraction, which is a fraction that equals one whole, it's going to be equal to itself. Yes? Okay, that's the first of 3 options we're going to have. So you kind of got that one real solid in your brain? Okay.
One thing I don't understand is why we can't put 4
You definitely could put 4/4.
I put 4.
4/4. That equals 1. She had said 4 and 4/4. That's way more than 1. That's actually 5. 4/4 does work. Good question. Okay? A fraction times a whole fraction equals itself. It's equal. Now, what do you think happens if we multiply any fraction by any number that is bigger than 1? What if we multiply this by a number that's bigger than 1? Will this answer be bigger than this or less than this? Bigger, of course. If you take something and you multiply it by something bigger than 1, you're going to get something bigger than your original, right? If I have 1 pizza and I multiply it by 2 or 5, I'm going to get more pizzas, right? Same thing with fractions. If I have my mixed number and I multiply it by something bigger than 1, right? So if I multiply it by, give me a fraction, I can't take it this way, something that is bigger than 1, right? So something that is going to be bigger than 1. Give me a fraction that's bigger than 1. Naomi? Nope, a fraction that's bigger than 1. What's a fraction, Heidi?
11/8.
11/8. How do you know that's more than 1, Heidi?
Because the top number is.
The numerator is bigger than the denominator. So 8/8 would be 1, right? 8/8 is 1, so 11/8 is more than 1. Yes? So if I take 2 2/3 times 11/8, is my answer going to be bigger than this or less than this?
Bigger.
It's going to be bigger, right? Greater than. Give me another fraction that's greater than 1 that will make our answer greater than the original. Zari?
12/4.
12/4, yeah, that's way more than 1. So that means if you take this times something that's more than 1, our answer is going to be greater than this original factor. Ella?
3/7.
3/7. Is that more than 1?
I mean, 7/3.
7/3. You caught it. Thank you. 7/3 is more than 1. So if I have 2 2/3 times 7/3, my answer is going to be bigger than that first factor. Yes? Does everyone understand that? Josie, give me one.
A billion and a million.
What's that?
A billion and a million.
1 billion millionths. Thank you, Josie, for making me work so hard. 1 billion, 1 millionth. This times 1 billion, 1 millionth. Well, that means you're multiplying it by something bigger than 1. So our answer is going to be greater than the first factor, yes? Lamar, are you going to work me hard here? What's your fraction that's bigger than 1?
1 trillion, 1 billion.
1 trillion
A trillion.
billions. I'm just going to add on. 1 trillion billions. Yes. Okay, so pause for a second here. Think with me. Think with me. Any fraction times a fraction that equals 1 is going to be equal to the first factor. Any fraction times a fraction that is bigger than 1, you're going to end up with an answer that is bigger than your first factor. Yes, that makes sense? The opposite is your last thing, and then you've probably got one of the harder things in multiplying fractions. If you have a second factor that is less than 1, what do you think will happen to your answer?
It'll get smaller.
It will be less than your original factor. Less than that.
Wouldn't it be
So
divided then?
give me a fraction that is less than 1. Yes.
2/3.
So if you have 2 2/3 and you're multiplying it by 2/3, which is less than a whole, it's going to get smaller than your original, right? Like, think about this.
Wouldn't it be division?
Just wait. Think of this. If I have a pizza and I'm saying I just want 2/3 of the pizza, it's going to end up being less than the original pizza, right? So, give me another example of something that is less than 1, a fraction less than 1, Bodhi.
6/8.
Say again?
6/8.
6/8. Any fraction or any number, any factor, times 6/8 of it, right? You're multiplying by something that's not even a whole. You're going to end up with a smaller number than your original factor. Okay? Michaela. 1 billion trillionths. Yes, that's less than a whole. So 2 2/3 times 1 billion trillionths is going to have a smaller answer, a smaller product than the first factor. Okay, hands down, some examples. You are going to tell me, think everybody in your brain, whether this is going to be, don't show me until I say go. You're going to say it's going to be greater than the original factor, equal, or less. Greater than, equal, or less than the original. So the original is going to be, you can pick anything, right? We're going to pick 7 1/5 times, I'm going to put something in here, and you're going to tell me, is it going to be greater than 7 1/5, less than 7 1/5, or equal? Greater, equal, less. 7 1/5 times 9/9. Go.
I can't see what's
7 1/5 times 9/9 is going to be equal. Why? Because 9/9 is equal to 1. Anything times 1, the answer will be equal. Yes? Here we go. What about 7 1/5 times 7/10? 7 1/5 times 7/10. Is your answer going to be more than 7/5, less, or equal? I see some people whose hands aren't up. You gotta give me your best thought what it's going to be. Any number times a fraction that is less than 1, your answer is going to be less than the first factor. Okay? Some of you are disengaged. I need your eyes. I need all four things on the floor, please. Don't be tipping back on your chairs. Your eyes should be up here, your hand ready, okay? How about 7 1/5 times 1/2? Greater than, less than, or equal? Any number times a fraction that's less than 1 is going to be less than the original. Less than, less than. How about this one? 7 1/5 times 11/10. Good, okay? How about 7 1/5 times 38/38? Equal, because it equals 1. Any number times 1 equals itself. Okay, you guys really got this quick. One more. 7 1/5 times 72/73. It's less than 1, So your answer is going to become less. Super amazing. Okay, what I'm going to do is I want you to open up your math workbook to lesson 8-4. 8-4.